Alright guys, here's a video on slope, aka rate of change. So, what is slope? Slope is the steepness of a line. It tells you the direction your line is going. You describe your slope with a fraction. The fraction is going to be rise over run. Okay? The rise is positive if from left to right the line is going up. The rise is negative if from left to right the line is going down. The run is always positive. Slope is represented with the variable m. So here it is, the variable m, that's saying that the slope is equal to rise over run. Now keep in mind, if your slope, now this plus minus, I don't want you to, maybe we want to do this, scratch this out, because all you really want is to understand that if it's going up, it's positive. If it's going down, it's negative. And the run is always positive. We're going to be looking at lines always from left to right. Okay, so again, the rise, it could be positive if it's going up, negative if it's going down, and you always look at lines like if you're reading a sentence from left to right, okay? Now, if you think about what rise really is really the difference in the y's, the change in the height, right? And on the xy plane, you have y values, and the difference in the y values is the rise. And the run is going to be the difference in the x values. So this is a formula that we need to memorize. Let's take a look down here and let's understand slope better, especially when we are visually seeing a line. We could actually count how much you rise and how much you run. So the very first thing you need to do is look at this line from left to right. Okay, you don't want to look at it from right to left. That's incorrect. You always want to have a positive run value. So you always want to start over here on the left side and work your way to the right. Okay, so anyhow, if we select 2 points, we have a nice point right here selected for us and a nice point right here selected for us. How much do you rise from this point all the way to this point? Well, you rise 1, 2, 3. Now you really do go up 3. You don't go down 3, right? You're going up 1, 2, 3. So that's the rise 3. So if we think about this line, the slope has a rise of positive 3. So let's go back to our dots here. I went up 1, 2, 3. Now let's go over 1, 2. The run is 2. So the slope for that line right there is 3 halves. Let's take a look at this line down here. We have one dot here, another dot over here. How many levels do I rise? Do I go up 1, 2 levels to get to this point? No, you only go up 1 level. So the rise is 1, and the run, always to the right, is 1, 2. Okay, so the rise is 1, m equals 1, and the run is 2. Okay, we haven't had to deal with negative slopes yet. Let's move on over here. Both of these are actually negative. If we think about this line right here, compare the left dot to the right dot. Of course, we're always going from left to right, not from right to left. So you're always looking at things from left going to the right. Okay, so you're up here. Are you going to be going up to get to this point, or are you going to be going down to get to that point? Obviously, you're going down. How many units are you going down? 1, 2, 3, 4, 5 units. So it's actually a negative 5. Let me put that right here. The slope has a negative 5 as the rise because it actually went down 1, 2, 3, 4, 5. Now, how much do you run? Remember, run is from left to right, so you're going 1, 2. So you're going to run 2 spaces. So the run is positive 2. So the slope for this line is negative 5 halves. Let's take a look at the other line. There's a dot right here and a dot right here. And actually, I'm not always going to give you these dots. You're going to have to find them, right? And what do I mean by find them? Look at coordinates that are nice on the line that you have graphed. So this is a nice coordinate. This is definitely not a nice coordinate because it's between the 3 and the 4 on the y-axis. This one's a nice coordinate. This one's not a nice coordinate. This one would be a nice coordinate. Anyways, since I gave you the dots here, the coordinates, let's use these two. From left to right, what are you doing? Are you going up? No, it's a negative rise. And how much do you actually go negative rise? You go down 1 unit. So that's a negative 1. If you want, you could visually show what you're doing here. You're going down 1 unit. That's 1 down, so that's a negative rise of 1. And you're going down over 1, 2 units, so that's a 2 of a run. So the slope is negative 1 over 2, or negative 1/2. But you don't have to draw any of that stuff. You could just count What do I mean by that? Oh, you go down 1 over 2. That's your answer, negative 1 over 2. So if you're going up from left to right, it's a positive slope. If you're going down from left to right, it's a negative slope. So on these next graphs that you see here, on this one, I just drew a line. I didn't even care about what coordinates it passed through. I just drew it that way. From left to right, it's going down. That means it's negative. From left to right, it's going up. That means it's positive. And we're just talking about slope, okay? Positive slope, negative slope. The slope 0. Remember, slope is steepness. How steep is this flat line? It's not steep at all. It's 0, not even steep. It's the opposite of steep. How steep is this guy? Man, that's so steep you can't define it. That's not steep. That's completely and totally vertical. So this is what we call an undefined slope, okay? Next, let's talk about the slope formula. You have to memorize this formula, okay? You have to memorize the formula. And how does the formula work? You don't have to see the graph. So like right here, we were looking at graphs. But for example, let's focus in on this graph right here that had the slope negative 5 halves. This coordinate up here, that was the coordinate negative 3, comma 3. This coordinate down here, that was the coordinate negative 1, comma negative 2. Okay? So what if you didn't have the graph? What if I just told you, hey, there's a line that passes through this coordinate and this coordinate? You could actually use the slope formula to calculate the answer, negative 5 halves. All you have to do is label your coordinates x and y, which is what they truly are, and label one of the coordinates your first coordinate, so you would call this 1, 1, and your second coordinate, calling it 2, 2, x2, y2, and then you could plug it into your answer, into your formula. That might not make too much sense right now. Let's look at an actual example up here. Examples. Okay, so I know my slope formula is this. And I also know that these coordinates are x and y values, so let me label them x1, y1, x2, y2. I want to call this one my first point, I want to call this one my second point. And now from here, it's just a question of looking at what's up here. It's y2, and that's going to be a 6. But this is what I recommend, guys. Rewrite the formula with empty spaces on the y2, y1, x2, x1. This is what I'm talking about, look. I rewrote the formula, but I don't have y2 and y1, x2 and x1. I just left blank spaces. Now I could actually see what my y2 value is. We know that y2 happens to be 6 in this case, so I put a 6 up here, okay? What is my y1 value that belongs on the top right? Oh, the y1 is 2, so let me put a 2 up here on the top right. And what is my x2 value on the bottom left? My x2 value is going to be 5, so let me put a 5 right here. And my x1 value on the bottom right is 3, so let me put a 3 over here. And that's my slope formula. All I have to do is work it out. 6 take away 2, the answer is 4. And 5 take away 3, the answer is 2. So my slope is 4 over 2. However, that could be reduced either to 2, or you could leave it as a fraction, 2 over 1. So m equals 2 is an acceptable answer, or you could say 2 over 1. Sometimes we leave it like a fraction just in case we're asked to graph. You could easily see that you're rising 2 and running 1, okay? So I hope that helps. Let me jump to one that has negative values involved. Let me take a look at, let's do number 3, okay? So once again, you have two coordinates. Let's label them x1, y1, and also x2, y2. And now let me write the formula, but without the actual y2, y1. Let me just write the division and the subtractions. There it is. And now, remembering the formula, it's y2, which is 1, minus y1, which is negative 5. So put a negative 5, over x2, which is negative 9. Put negative 9 right here. Minus x1, which is negative 4. So let's put a negative 4 over here. Now, do you see why it's important that we do the division and subtraction signs first? Because now we will not make the mistake. We will clearly see that the minus minus changes to plus plus. So let me do that. Plus plus, plus plus. And our final answer here will be 6 over negative 5. However, remember, in terms of slope, you want your rise to be either positive or negative. You want your run to always be positive. So you don't want to leave this minus sign right there. Let's actually rewrite the final answer. M equals, you could either put the negative up on top with the 6, or you could technically put it out here in front, right with the division bar, with the fraction bar. It's up to you. So that's the answer there. And of course, if you're working on a slope formula problem and you end up with a 0 on top, anytime you have a 0 on top over any number, your answer will be 0. If you get a calculator and do 0 divided by 2, the answer is 0. 0 divided by 50, the answer is 0. 0 divided by any number, it is 0. And again, likewise, if you try to do any number divided by 0, if you get 0 underneath, and you try to do that on a calculator, that's undefined. It doesn't work. Undefined. Okay? So if 0 is on top, the answer is 0. If 0 is underneath, the answer is undefined. Now, down here, we do have some examples where you do get 0 on top, which would be 0, 0 underneath, which is undefined. However, on our homework tonight, we actually do not have any of those unique problems where the slope is undefined. So I'm going to pause it right there, and good luck on your homework.